Everybody, today we are discussing the next topic, that is the oxyacids of the halogen. This is the last topic of representative element 2. So the halogen form only one oxyacids, so that is the HOF, in which the hypochlorous acid, in which the oxidation state is +1, and chlorine form four different type of the oxyacid, that is HOCl, HCl O2, HCl O3 and HCl O4, and bromine form three different type of oxyacid, that is HOBr, HBrO3 and HBrO4, and iodine form the three type of oxyacid, that is HOI, HiO3 and HiO4. Next, we are moving into the different structures of the oxyacids of the chlorine. First is hypochlorous acid. So, hypochlorous acid, in which the chlorine is exists in the +1 oxidation state and the molecular formula is HOCl. This is the structure of the HOCl, in which the bond angle is 103, and it is an angular shape, and in which the chlorine exists in the sp3 hybridization state, and the chlorine atom is attached to one OH group, and here the H plus ion is easily detachable from the OH group. That's why it is a monobasic acid. And in HOCl decomposes in water to form H3O plus ClO minus ion. So it shows that HOCl is a monobasic acid. And now here the chlorine is exists in the sp3 hybridization. So after the hybridization we will get 4 sp3 hybridized orbital, in which 3 of them are occupied by the lone pair of electron, and one of the sp3 hybridized orbital atom is used to form the sigma bond with the p orbital of the oxygen atom. So here, in which the chlorine is represented by the green color, and there are 3 lone pair are present, and this 3 lone pair is exist in the sp3 hybridized orbital, and one orbital is used for forming the sigma bond with the oxygen atom. Next is the chlorous acid, in which chlorine exists in the +3 oxidation state and molecular formula is HCl O2. Just by add one oxygen atom and repeatedly, so we will get the oxyacids of the chlorine. Here also we can see that only one OH group is attached to the chlorine atom, so it is a monobasic acid, and it is very difficult to liberate H plus ion. That's why it is a weak monobasic acid. As in the case of HClO, the HCl O2 is also exist in sp3 hybridization, and in HCl O2 decomposes in water to form H3 plus and ClO2 minus ion. It also shows that HCl O2 is a monobasic acid. And here we can see that there are 4 sp3 hybridized orbital, in which 2 of them are occupied by the lone pair of electron, and one is used to form the sigma bond with the oxygen atom, and similarly the other sp3 hybridized orbital is used to form the sigma bond with the p orbital of the oxygen atom. And this is the structure of the HCl O2. And next is the chloric acid, that is in which the chlorine exists in the +5 oxidation state and molecular formula is HCl O3. And here also there is one OH group is attached to the chlorine atom. That's why it is a monobasic acid. And the OH minus ion can generate H plus ion can generate very easily. That's why it is a strong monobasic acid. The hybridization is sp3 hybridization, and it is a pyramidal geometry. And in the 4 sp3 hybridized orbital is exist in the chlorine, in which the 3 of them are used to form the sigma bond, one with the the p orbital of the oxygen atom. The 3p orbital is used to form the sigma bond, and the pi bond is formed by the d orbital of the chlorine atom and p orbital of the oxygen atom. That's why this is a lateral overlapping, and this pi bond is known as d pi p pi or bonding. And ClO3 is dissociated in water and to form the ClO3 minus and H3O plus. Next is the perchloric acid, that is the chlorine exists in the +7 oxidation state, and the molecular formula is HCl O4. And here also the one of the OH group is attached to the chlorine atom. That's why it is a monobasic acid, and the compound liberate H plus ion very readily. That's why it is a strong monobasic acid, and it is the most stable oxyacids of the chlorine. As in the other case, the chlorine is also exist in the sp3 hybridization, and the geometry it's a pyramidal geometry. And the 3 of the sigma bond is formed by the sp3 hybridized orbital of the chlorine atom and the p orbital of the oxygen, and the pi bond is formed by the d orbital of the chlorine and p orbital of the oxygen atom, and it is a lateral overlapping, and this bond is known as d pi p pi bond. And HCl O4 dissociate to form H plus Cl O4 minus ion. It shows that the compound is a monobasic acid. Now we are moving into the very important topic. The structure of the oxyacids of the chlorine is very important, and now we are moving into the comparison of the acidic strength of the oxyacids of the chlorine. That is also very important. There are two reasons. First is the acidic strength increases with increasing oxidation number of the chlorine. Here we can see that in the first acid, that is hypochlorous acid, the chlorine exists in the +1 oxidation state. In the chlorous acid, the chlorine exists in the +3 oxidation state. In the chloric acid, the chlorine exists in the +5 oxidation state. In the perchloric acid, the chlorine exists in the +7 oxidation state. So as the oxidation state of the oxyacids of the chlorine increases, the acidic property is also increases. The second point, greater the stability of the conjugate base, stronger will be the acid. See here in the first example, HClO, it will dissociate to form H plus ClO minus. This is the structure of the ClO minus, in which the chlorine atom exists in the sp3 hybridization state, and 3 of the sp3 hybridized orbital is exist in the contain the lone pair of electron, and the other is formed to form the sigma bond with the oxygen, and in the conjugate base negative charge is occupied only in the oxygen, and there is only one structure. Whereas in the case of the ClO2 minus, there are two resonating structure is available, and in the sp3 hybridized orbital, 2 of them is occupied by the lone pair of electron, and there are 2 oxygen atom, and the negative charge is delocalized. That's why it is a resonance structure is available. 2 resonance structure is available. Whereas in the case of the ClO3 minus, there are 3 resonance structure is available. And in the case of ClO4 minus, 4 structure is available. As the structure of the resonance structures increases, as the number of the resonance structure increases, the stability is also increases. So the acidic strength depend upon the 2 factor. First one, higher the oxidation state, higher the acid. Second one, higher the number of the resonance structure, the acidic strength is also increases. Thank you.